Measurement problem is a problem in physics that seems to be very difficult to answer because we're dealing with, once again, mathematics and reality. Now, here we have psi, which is a probability wave, which seems to be spread out, but more likely in one place, but we're not sure what it is. And then we measure it, or at least we measure a property. And then we get a very distinct, for example, position or spin or whatever. These could happen, but they are, in terms of position, but they're less likely because the probability falls off. Now, mathematically, many superpositions work. For example, a square wave is a superposition of sine waves. These sine waves can be, put a square wave through a frequency analyzer, which shows you the sine waves that make it up. A standing wave, which is not moving, can be a traveling wave this way and a traveling wave that way, and they interact by giving a standing wave here. Now, we have some physical entity and we can add various things, mix 1, 2, 3 to get A. The mixing of these individual stuff gives A. Concrete, for example, is parts of 1 water, 2 sand, 3 stone. And if we change the ratios, the mixing, the time and temperature, it will change the properties of the concrete. That's a sort of a superposition. Now if we take a coin, heads and tails, and we throw it up in the air such that it's spinning on the x-axis, the y-axis and the z-axis, the probability of determining heads or tails and the orientation of the head, once it's stopped, you can superimpose all 3 spins. You can measure at time t1 or t2. So when it's stopped, when you stop it, you can measure the properties. If a measure is to let the coin fall onto a flat surface and stop spinning, you get heads or tails at some angle, but you've had to stop the spinning, and the point at which you stop the spinning determines what you get. If the measure is a flash photo, then heads and tails and the angle are all equally probable at various times. You will just see them all happening. Now, a spinning coin is a time-varying property. Measuring interferes with the spinning and destroys the motion. Timing the measurement can bias the results. Now, I guess the point I'm trying to make here with difficulty is that the spinning coin is a real physical entity. The probability waveform associated with this is a probability of how a measurement of a spinning coin will result in a property of the coin being revealed. If we take the twin slit experiment, and there's various ways of trying to determine before and after whether it's gone through slit 1 or slit 2. Key thing is, any measurement destroys or changes the entity being measured. It doesn't matter how slight or how you infer it. There's no such thing as an undetectable measurement. Switching off a detector means switching off the signal interfering with the entity. So switching off the detector, sometimes what's interfering with the measurement doesn't change whether you switch it on or off. Another way they tried it was to see which goes through, was to send some through there and bounce some off, so that you didn't actually interfere with what was going through, but you send a sample of what was going through. When you looked at them, there seemed to be interference, but on average there wasn't. So this whole thing of measuring, to me, I must admit that I don't see it as collapsing. I just see it as making a determination of the probability.